All right, Dave again here in the shop. We've got our Arduino and load cell project um, finished up, and it's operational. So this guy is set up to measure the load hanging from this load cell, and put a little piece of code in it to capture the max weight on it as you load it up. So we're gonna utilize this, and we're gonna take our 3D printed little bracket that we made and see what kind of a load it can hold to the breaking point. Part of what we got to do today is figure out a little mechanism, some sort of a mount to be able to hang this from the load cell. So we'll build that up, and then we'll go give this assembly a first test and try it on this part, and we'll see what happens. Hopefully we'll get a good measurement of the breaking point for it. All right, let me explain the test fixture. So we've got the load cell, and it's set up with the Arduino controller that'll measure the weight in grams. And then what I added to that was a little fixture to hold my bracket that I'm testing. And of course that then holds a bucket that I'm going to fill up with water. And then I put a little stand under it. So hopefully I don't make a mess when the bracket breaks and then the water bucket falls, hopefully 1 inch, and I just get slightly splashed. So that's the test rig. So what we'll do is, then we've got a water hose with a valve here. We'll use that to slowly fill up the bucket, and we will load test the part. Oh, one other thing, on the controller, there is a little piece in there to set maximum load. So as it's measuring the weight, it'll be constantly collecting that maximum load figure. Hopefully, if everything works out as planned, then when it breaks, it'll break at the maximum load. The weight pressure will be released, and we'll have a value on the Arduino that tells us how much this particular little 3D printed bracket will hold. So let's see what happens. All right, we've got the bucket disconnected, and what we'll do is we'll take our Arduino, see if I can get that in the field of view. I'll zoom in a little bit. And what we're going to do is hit the reset button on it. And that's going to zero out, do the tare weight, so that now we've got it set to 0, so that we'll measure exactly the weight of the bucket and the water that is applied to the test part. I'm going to connect up the bucket to the test part. So there we go. The weight reads about 833 grams. We're going to start adding water into this. Alright, we're filling up the bucket. We've got probably about a gallon in so far. And we're going to keep loading. I measured the bucket earlier. With it filled to the brim, it's 45 pounds. So we will see how the part does under that weight. Alright, I heard it snap. Remove the bucket, and now with closer inspection we can see that the part snapped. We heard that snap, but we didn't have a second camera to monitor the point at which it snapped. It did record a maximum of 14,212 grams. That's about 35 pounds or so. And we know that the bucket completely filled up to the brim is about 45 pounds. So clearly the part broke. The maximum was recorded. The bucket then rested on the wooden box, keep it from falling and splashing and making a big mess. So I think it was successful. I think that this part in this test held about 35 pounds. You know, you can see it's kind of bent. It's still together. I mean, we didn't rip the whole thing off of it. But clearly, we snapped it. We heard the snap. We heard some breaking, and certainly would have weakened the part. Now the next step as we move forward, we'll make more parts. I got the 3D printer running right now, cranking out more parts that we can break. PLA in the red and PET G in the white. We're going to see if there is a difference in these two materials. I've heard that the PET G will be stronger. Oh, we'll find out. We'll see what happens, and we'll measure the results, and then show you what our findings are. Thanks for watching, and thanks for coming into the shop with me.